So today's topic is offline capable web applications. What I mean by that, let me introduce it. First, looking at the history of the web technologies, we come from a long way. We started with lots of innovation from the 90s to the 98 year about that. We invented a lot of new languages and technologies like HTML, CSS, JavaScript, XML, SSS, cookies, and so on. We got the first very popular web browsers. And so we had a lot of innovation at that time. After that, we had a long period of stagnation, let's say like that, notably because of the monopoly of Internet Explorer. So we had a few technologies that came in, but the user experience at this time did not change a lot. And we had again the kind of revolution for the web tech starting from 27 years, let's say, notably because of the apparition of Chrome web browser and also a new kind of website appear like social networks. And finally, we got smartphones that changed the deal a lot. And so after 27, website changed a lot thanks to the one web approach. We got responsive web design. We got ton of new specs, new CSS layouts, new JavaScript APIs, stuff like that. So it changed a lot. And after, let's say 2014, if we look at the innovation in web tech, we had some things, but it's mostly developer experience, let's say, instead of user experience. We got ECMAScript 6. We moved to yearly updates for the JavaScript specification. TypeScript appeared, and it is now adopted very widely. We have modern CSS specs. We can now unplug the transpilers that we had before, like Babel, PostCSS. All these tool chains can be unplugged now that we have a proper support for these new specifications. And the build toolchain, it has been simplified and speed up a lot. So thanks to Vite, ESBuild, Parcel, this kind of projects. And we have also evergreen browser support, thanks to the death of Internet Explorer. Finally, we have a sane environment to work with modern specs. But all these things that I'm talking about are developer experience. There are not a lot of changes on the user side. So if you look at some example of popular websites, they didn't change a lot, I mean, from a technological point of view, from the years 2014 to 2024. So how can we change that? How can we improve the web user experience in 2024? So we have seen that some of the aspects about the user experience have been almost solved, like the design, the performance, the accessibility. All these topics, we have invested a lot of time and effort into it, with design evolving a lot thanks to the one web approach, thanks to responsive web design, adaptive web design, and now it's became a standard for website creation. The performance, we bring a lot of effort into it as well, notably thanks to the frameworks and tooling, the build toolchain that change, etc. And for the accessibility, I think everyone is concerned about accessibility. We have trainings, we have legal issues if you don't make an accessible website. So these are almost solved problems. Of course, we can always put more effort into it, but it's not the one thing that I think will be the most important to improve web user experience today. There's one thing, though, that I think needs to be addressed for websites, that we can put some effort into it to largely improve websites, at least from the user's perspective, and it is the resilience. So what do I mean by resilience? I mean basically this dinosaur, there is no internet connection page. So when you are browsing a website and you lost your internet connection, it's kind of granted that you will get to this kind of web page, error web page. But actually, is it something that is absolutely necessary? Do we have to get to this kind of page, error page, or can we improve that? Can we change that? Well, it turns out that we can. And we can definitely bring some offline capabilities to websites today. So this is not a fatality. And so I propose you to kill the dinosaur in 2024. My point for this talk is that all modern web apps could and should have some offline capabilities. So what does it mean, offline capable? Well, you could ask the same question with all the different aspects that we just talked about. For example, what does it mean to be performant or accessible or have a good design? All these things, of course, have no strict definition. It's mostly an effort that you put into your app as a developer. And so it will always depend and you can always push it further. It's a continuous and progressive area of improvement. But what do we mean by offline capable? Basically, get rid of the dinosaur, get rid of error pages, and be able to continue to at least browse your web app once you lost your internet connection. So this may sound like progressive web applications. There are this kind of promise with progressive web applications that you could continue to use your application offline. And yes, that's true. Progressive web app, it's kind of, let's say, a quality label or a made up term by the Chrome team to describe what could be a good user experience on the web thanks to all the new specifications that have been added to the web these last years. And so the promise of progressive web apps was to get some kind of native-like experience on websites. But people remember mainly progressive web apps for the installation part, the fact that you can browse a website like it was an application installed on your device. So on desktop, it would be a desktop icon. On mobile, it would be in your application grid. But not much about offline usage, to be honest. And so I think that some people maybe forget this part when talking about progressive web applications, but offline capabilities are definitely an important part of PWA. And so this is not new. I mean, we can and we have made prototypes of offline capable web applications starting from 2012 when I was just an intern at Worldline. The technology today to make offline capable website is ready and mature. Back in the days, we used the old application cache spec. Today, it has been changed. We have service workers, for example. But it's the same. We can still make offline web applications for a long time now. And is this needed? I think that today is the best selling point that you could have to sell, innovation and new shiny tech on the web. I think offline capabilities would be a major force, a major strength for your proposition of a website. Because it's not only about offline, it's about all the different issues that you may have with network, the small disconnections, the lag, and it helps improving both the resilience to bugs and the resilience to small network issues. And globally, it will make your application more smooth and more performant. If you want to talk numbers, there is this website, pwastats.com, which presents lots of interesting testimonies about how progressive web apps change their business and improve their numbers for all kinds of different business. So I think it's proven at this point that offline capabilities, or at least all the new stuff that you can add to bring more resilience to your website, will help selling your product and have greater user engagement and revenue. Okay, so how do we get there? Let's see. First, to be able to apply offline capabilities to your website, there's one mandatory step. It is client-side rendering. This makes sense because if you rely on your server to make the rendering of your web application, but you lose the internet connection, there is no more server. And so there is no more rendering, there is no more application. So obviously, the first step is client-side rendering, which shouldn't be a big deal because today most modern frameworks in JavaScript are using client-side rendering. So we can talk Angular, React, Vue.js, Svelte, you name it. And so what brings client-side rendering? Obviously, it renders on the client. That means that you don't need a server to have rendering on your application. Of course, you need data from the server. And so it happens that when bringing client-side rendering, you're going to split data and the static files, the static assets like JavaScript, CSS, HTML that is needed for the rendering of your app. Before, it was one request, one response from the server containing the HTML with data. And now these things are split together, so you have a JSON on one side and static files on the other side. And this is really interesting because we can address different cache strategies based on if it's a static file or a JSON file. Once you have client-side rendering, you should already be at what I call the level 0 of offline capabilities, which is the resilience to temporary network failures. So once you have client-side rendering, since you have splitted data and static files, when you are doing a request, so it can be a read request or a write request, making change on the backend, you can intercept the error, the network error, and provide in JavaScript a message, a feedback, visual feedback to your user to inform it that the network failed. So it's the default behavior for any Vue.js, Angular, React application. You are able to provide basic error management and have a visual feedback, manage some client-side timeouts so that the user knows that he has lost his connection and he can try again once he retrieves it. So the application doesn't break. That's the main point of the level 0 of offline capabilities is your application does not break when you lose network. You have error messages, but that's it. But if you press the reload button of your browser and you lose the internet connection, if you have done nothing more than that, you still will have the error message, the error page with the dinosaur. So, how can we improve that? So we have this new API called the Service Worker API, and it's a very interesting one. Basically, a service worker is kind of another JavaScript program that is running in a separate thread than your main thread of your web application, and that can continue to run even when your application is not in the foreground of your device. So it can work in the background and can do many interesting things. This code that is running in this service worker can act somehow like a proxy for the network. That means that any request, any response, any network exchange between the browser and the server can be intercepted through this service worker and manipulated. So it will be very interesting, for example, to use it to implement a local cache, more than just HTTP cache, but using the local client-side cache to be able to store some responses. So for example, you have here the code to manage the saving in the cache of static files. And when we lose the internet connection, we will get the same event listener on the fetch event. So we will be able to intercept the network response, see that there is an error, look at the cache, and send the cached response instead. So we have local persistent data storages technologies in client-side JavaScript today. We have local storage, for example, which is a simple key-value storage, and we have IndexedDB, which is closer to a transactional database and help managing large structures, large blobs of data. So if you have a quite simple problem, you can go with local storage. And if you manage lots of information in your application, you probably want to have a look at IndexedDB. Thanks to Service Worker and local persistent data storage on the client, we are able to move to the level 1 of offline capabilities, which is snapshot-based offline. Basically, what it means is that when you lose the internet network, if you reload the page, you should get back to the same exact state that you were just before. So it will just be a snapshot. That means that you won't be able to continue to interact with the application. You can navigate, but you cannot have write actions, have edit actions. And so your application should be just a snapshot of the last state where you have a network. At this stage, you are able to make some basic online-offline detection. You can provide a feedback to the user as well, visual feedback. You lost your network, please do something. But you will disable all the actions that user can make when offline. So that means that in your local state, you're going to have a flag saying connected or not, and you are going to change your application to become some kind of read-only when you lose the network. You will run a service worker and you will cache all the critical static files that you need to render your applications so that once you reload the page, the service worker returns the cache response and then the application can boot and use the last snapshot, the last state that we have. This implies, of course, that this state is fully centralized on the client. You need the entire state to be able to render the application. To be able to have a last snapshot of data, it's quite easy. Every time you have a change in your centralized state, you just persist the latest state, either in local storage or IndexedDB. So if you get to this point, your application should be able to load and to have the same state after refresh, whatever if you are online or offline. Can we do more than that? Yes, we can. The next step, once you are at this point, is to start to add more logic to your service worker and bring some kind of new layer to your application. So you already know the view and model composition. These are the two layers that are usually dealt when working on a web application. The model is taking care of all the logic and the state of your application, and the view is going to be the result of the rendering of your framework, Vue, Angular, React, based on your local state. And so you have this exchange between model and view every time. What you can do is to add a new layer above the model and the view, which I call the network interface. And in this layer, you will have, for example, the service worker code, but you can do much more than that. For example, you can add more logic to take care of your request. For example, stacking your requests. If there are several components that needs the same data and are doing the same request, you can stack them, you can merge them, you can automatically retry in the background if one of these requests has failed. You can improve a lot the way you manage your errors in case you have network errors. And you can add much more value to a table thanks to this network interface. For example, I had projects where I added some kind of runtime type checking. So that is validating at runtime the content of the network request and responses body to make sure that everything is all right and that we don't have any issue. Of course, you can rely on server-side error management, and you can rely on a TypeScript in your code base to improve the resilience and make sure that these are the correct types. But I think that validating at runtime at the last moment when you have to use it is also a good idea if you are a bit concerned about the types in your requests. And of course, this network interface would be the perfect opportunity to add more advanced cache strategies to be able to improve the performance of your application. So network interface, service worker is part of it. Usually we try to keep the service worker code as light as possible. So that means that all the new stuff that I just talked about, maybe it's not a good idea to put it in the service worker code, even if you can do it. Maybe it would be easier to do it on your main application thread as separate functions. In addition to this network interface, we can also work with optimistic UI. So what is called optimistic UI is basically the principle that mostly 99% of requests are going to be successful. That means when you are doing a request, you can expect most of the time to have the proper result, to have the request validated by the server. And it happens in your web applications that most of the time, when you are doing a request, you can already predict the result by the server. That means that the server is not going to return you some data that you absolutely need to be able to move to the next step, to show the next page, and so on. And so what we can do with optimistic UI is just going to assume that the server is going to respond correctly, but there won't be any error. And we can just improve performance like that. Just change immediately on the local client state, to let's say assume that the server has responded correctly. But if it happens then after that the server returns an error, then that means that we need to inform the user that what he thought was correct is indeed incorrect. And so you need to roll back to a previous state. So this can be a bit confusing and not desirable, not being sure that everything is okay with your request. But actually, it is something that is already used in many web applications that almost all of you use on a daily basis. For example, if you are sending an email or if you are sending a message in an instant messaging application, they are using optimistic UI. And so you can see your message is sent, but sometimes you have these little icons, error icons, with proposal to retry or stuff like that. These are examples of optimistic UI. So using optimistic UI and adding more cache strategies to the network interface, Let us bring your application to the next level, the level 2, which I call cache first offline capabilities. So cache first means that we are going to use primarily the cached static files to reduce the loading times, and we are going to use optimistic UI when possible, and of course rollback on error. And thanks to these two enhancements, we are able to largely improve the performance and the smoothness of a web application. These have some implications for your data management. For example, you need to identify which part of the data is fresh, that is validated by the server, and which one is in a stale state that is waiting for the confirmation, waiting to be validated, synchronized on the server. So the way I usually deal with that is adding a boolean on my data objects, my data structures. Usually I call it stale. And if stale is true, that means that we have to wait for the server to have a proper response to make sure that this data is validated, is persisted on the server side. So thanks to the network interface, we can stack the pending requests. That means that if we lose our internet connections, we are able to unstack to just take the different requests in our stack, send them one by one until we have a successful response. That means that we got back our network. We are also able to automatically retry this failed request in the background. For example, on some projects, I lose the timeout to send the request after 1, 2, 3, 6, 10 seconds on a progressive incrementing delay, just to make sure that we can send the request as soon as possible without saturating the network. So the end goal of this level 2 cache first is that the bad network conditions should not block the user in the flow in his application. He should be able to continue to use the application. The one limitation that we would have with cache first is that when we have stale data, when we have objects and data structures that are not persisted yet on the server, we are going to prevent the user doing some actions on it, because it will be complicated, to enable the user to work on something that has not been validated by the server in the first place. So there is one more level for offline capabilities. The level 3 is what I call transparent background synchronization, and this one is not easy, but it's the most impressive one, I think. Basically, the limitation that we had with level 2, which is we are not able to edit stale data. We need to wait for the network connection to be retrieved and for all the stale data to be validated on the server side before being able to modify and work on this data. This limitation is going away with level 3. We are basically allowing all the actions that the user can do on a web application when offline. But to be able to do that implies being able to synchronize states that are very different from one to each other. So we need to manage some kind of synchronization logic to be able to handle write conflicts that will happen with two different states. For example, if a user has been offline for more than 1 hour, you have a very different state after 1 hour of work with the state that you have on the server. And so you need to synchronize these two states. So this should remind you something about developers and how they work. We use Git that is very similar to this kind of process. We work on our project, and at the end of the day, we make a commit, we push our work to the Git repository, the centralized repository. And of course, there are other developers that have done the same, which means that we need to synchronize the different states at the end of the day. And so this kind of write conflicts management is a bit similar here. We need to be able to find the proper logic to be able to synchronize this state. This implies some user interface for that, of course. You need some synchronization indicator. You need some feedback for the user when you have write conflicts to decide what the user should do. But it's doable. The way most people address this at a development point of view for developers is to get back to very simple operations. For example, Google Docs is doing that, who has an offline mode. Google Docs is going to focus on very simple actions done on a document. That is adding some characters or removing a word or deleting an entire paragraph, things like that. And so, because these actions are very simple, it's quite easy to synchronize. You know that If you have two actions that have added a paragraph, you just need to add both paragraphs in the end. So it's very easy to synchronize. This is the kind of logic that you need to do if you want to add this level on your application. You need to simplify the operations done on your resources, on your data, and get back to very simple operations that can be easily synchronized. This can be done with almost all kinds of data structure. Sometimes it's more complicated than others, especially if your data is very intricate between each other, if you add a lot of interactions and relations between the different parts of your data. But this should be doable. So this is the first step. The second step is a new specification that has been added and supported quite recently on service workers, which is transparent background synchronization. So the background periodic synchronization API in service workers allows to run some code in the background periodically, even when the application is not in the foreground. So that means that even if you stopped working on the web application and move to something else or put your device in your pocket, if the network connection is retrieved, you are able to make your service worker synchronize all the state, all the offline state with the server state in the background. And so this is very impressive and very useful to synchronize as much as possible. And so thanks to these two things, you should get to a level where your application can be used either offline or online or with bad network, high latency, and so on, without the user noticing, basically, because you have the exact same interactions, exact same actions, whatever if you are online or offline. So the user doesn't have to worry about his network connection anymore, and this is a much appreciated improvement for user experience. If you get to level 3, there is a bonus, is that it's very easy now to add a collaborative editing on your application, because addressing different users working on the same resource is basically the same thing. You need to manage state synchronization and write conflicts. So if you have done that, all this logic, it's quite easy to add collaborative editing or multiplayer, as we say it, to your web application. It's kind of very easy to get from this level of offline capabilities to multiplayer capabilities. And this has been done by many applications out there, like Google Documents, for example. It's very easy to edit a document with several people at the same time. And so we did the same thing for our prototypes here at Worldline with offline capabilities. So I know that that's a lot to handle, that's a lot of stuff to take care of, and this can be a bit frightening, but I like to finish by a positive tone. If you remember, responsive web design back in 2012, it was not a pleasure. It was very difficult, and some people already say that it was almost impossible. You never will be able to manage all these different devices. Look at all the different smartphones that we have, all the different browsers that we need to take care. It's impossible. And they have been proven wrong, because today we address these issues. We are able to use responsive web design. We have the one web approach. Responsive web design becomes the norm in web design, and I think that we can do the same with offline capabilities. I think that once we have the proper tools, once we have the proper experience and methodologies to get there, to get to this level of offline capabilities, it will become easier and easier, and I think that we will be able, at some point in the future, to bring this kind of offline capabilities on all the websites without putting too much effort into it. At least, that's my belief. But to get there, we need to do all these steps. We need to invest time. We need to adopt progressively offline capabilities. So I show you today the 3 levels of offline capabilities. I'm going to assume that most of you start from level 0. And so you can get to level 1 using progressive web applications and service workers and working on your local state management. You can get to level 2 by addressing the network interface layer, adding optimistic UI, adding more advanced cache strategies on your data. And you can get to level 3, if you're really motivated, by working on code synchronization, logic synchronization, and collaborative edition on parts of your application. So we have some open trainings for the progressive web apps part and optimistic UI and cache strategies. And for the advanced synchronization logic, we have nothing on open source right now. But this is some some territory that we are exploring, we are continuing to explore today, and there are lots of interesting stuff that can happen at this level. So the key messages I wanted to give you on this talk is that first, all modern web applications should be offline capable because it's very important for the user experience. They can be gradually added to an application. It's not a black or white thing. You don't have to address everything at once. You can go progressively from level 0 to 1, 2, 3. And the last part is that when talking about offline capabilities, we are not only talking about offline, like plugging out the cable, but also all the different small network issues that the user can have. And since we are today in an era when most of people are using mobile networks, and these are still some network connectivity issues, I think that it's an important part of any web application to be able to deal and be more resilient to this kind of small network failures, especially on mobile. I think that all of this should lead to a much smoother and much appreciable user experience in general. So I hope that you learned some things, and let's kill the dinosaur together.